All right, here's the warm-up for section 2 in unit 3, square roots and cube roots. If you remember from back in the day, a squared plus b squared equals c squared is the Pythagorean theorem, and it works on right triangles. So if you cover most of this up, right here we have side squared, which is like a squared. We'll call this a, and then we'll call this b. So you got a squared, b squared, and that would be c. So 2 squared plus 3 squared is equal to c squared. So see if you can find c without me. 4 plus 9 is equal to c squared. 13 is equal to c squared. And then you take the square root. We don't need the plus or minus the square root of 13 because the side of a triangle is positive. So this is the square root of 13. And it doesn't take too long to figure out that this side would also be the square root of 13 because we have the same triangles on all the corners. So we're finding the area of this square right here, this square right here, that area right there. So area is just length times width, or in a square, it's just the two sides multiplied to each other. So area of A, B, C, D would be equal to the square root of 13 times the square root of 13. And when you multiply that two square roots together, you just get 13. And it's square units, so I'll say 13 square units. So that's kind of a fast trick you can do there. It's like the square root of 5 times the square root of 5 is just equal to 5 because it multiplies up to the square root of 25, which takes you back to 5. It's hard to know what 13 times 13 is. I know what it is, but it's not as easy for you. Square root of 2 times the square root of 2 would be the square root of 4, which just takes me back to the square root of 2. So that's a fast trick you can know. Square root of 4 times the square root of 4 would be square root of 16, which is equal to 4 again. But that's kind of silly because I could have just done those right away. How about 6? Square root of 6 times the square root of 6 is the square root of 36, which just takes me back to 6. So that's kind of a pattern that you can notice. Basically what we're getting at here is if the area of this is 13, the square root, the root of the square is the square root of 13. So the side is the square root. So if you know the area, the side is the square root. So if you know the area, then the square root is the length of the side of the square. All right, so 13 side square root of 13. And that's what this is all about. Finding these different areas. Like C is really easy because it's 2 by 2. So C has an area of 4 and the length is 2, and the square root of 4 is 2. And then A is easy. Area is 1, right? It's just 1 square, and the square root of 1 is 1. And then you get to the trickier ones. So we can kind of do this the same thing here. This is 2, and this is 2. So 1, 2, 1, 2. So we get 2 squared plus 2 squared, that's 4, is equal to c squared. So this squared plus this squared, because the length is 2, so 2 squared plus 2 squared, that would be 4 plus 4 is 8. So c squared is equal to 8. So that means this is the square root of 8, that side's the square root of 8. And again, when you multiply those together, you're back to 8 again. So it's 8 square root of 8. So that's kind of the connection with those. This would be an area of actually 2, because it's 1 and 1, and you add those together, you get 2. So c squared is 2. So the area is 2, and this side is the square root of 2. And then here, this is 1 by 2, so it would be 1, 2. So that would be 1 squared is 1, 2 squared, you get 5, right? So it's the square root of 5, which means the area is 5. And that kind of makes sense with the order, because they get larger as you go. But it's the same as the warm-up. You're using the Pythagorean theorem to find that. And it's just this relationship they're getting at. If the area is 5, then the square root. All right. Now, cube root is the length of the side of the cube. So the length of the side of the cube is the cube root. So a cube has edge length of 3. What's the volume? Well, 3 times 3 times 3 is 27. So it's 27 units cubed. A cube has an edge length of 4. What's the volume of it? So it would be 4 times 4 times 4. That should be 64. And then a cube has a volume of 8. What is the... Oh, so now we're going backwards. So if the volume is 8, the length of the side is the cube root of 8. Well, what is the cube root of 8? Well, 8 would be made up of a bunch of 2's, right? 2 times 2 times 2. So the side would be 2. So that's how that works. So if we labeled this 2 and this 2, and then a height of 2, 2 times 2 times 2, have a volume of 8. Now you're supposed to put these on the scale here. Let me show you where the cube root button is on the calculator, and that'll make that easier. So all the good stuff on the graphing calculator is underneath the math menu. So you hit math, and then you got the cube root key right there, number 4. So the math button is here. All right, down here, cube root, and then cube root of 500. Before I hit enter, we know that 10 times 10 times 10 is 1,000. So it's going to be kind of up at this upper end here. It's between 7 and 8. It's almost 8. So the cube root of 500 goes right there. So basically 8 times 8 times 8 would be too much. 8 times 8 times 8 is 512. So that's too much. 100, well, 5 times 5 times 5 is 125. So 4 times 4 times 4 is not enough. So it's between 4 and 5. So I'll go up here, I'll execute this, bring it down, and then I'll put in a 100 instead of a 500. Whoops. So it's between 4 and 5. Yep. So cube root of 100 goes there. So you could figure out the other ones of those. So basically the summary of this, all this says is that if this is B, right, if the area is B, the length of the side of the cube is the cube root. Right, so if it's B, sorry, not cube root, square root. So if the area is B, then the length of the side is the square root of B. If the volume of this is A, then the length of the side is the cube root of A. That's it. That's the lesson right there. All right, now you're ready for the purple page. So do the purple page today and turn it in. All right, it should be pretty self-explanatory. We got the rules of exponents on here. This is the right page, isn't it? Yep. Got the rules of exponents, and you got the area and the filling out the table here, and then between what two whole numbers is that closest to? So you can figure out what that is. Like 5 times 5, 6 times 6, 7 times 7. 7 times 7 is 49. That's too much, right? 6 times 6, so it's between two whole numbers. So you can kind of figure out what that means. All right. Bye-bye.